Hello again. I'm back here with the same outfit I had on for activity 4 because I'm doing this Monday afternoon. All right, and at this point you should have written in the key question for electromagnets. Okay. Let's see, what page is that on? 65. All right. Which is how do electromagnets and buzzers work? And then you should define electromagnet, which is on page 65 as well. Okay. Exploration 1. Under what circumstances does a coil of wire work? Okay, so I have my wire here wrapped around, but the first thing it says is to, I just need one of these, I believe. Ooh, that was a bad sound. Okay, and it says take this out, attach here, yeah, and here, yeah, okay, and then bring the, I don't know if you guys can see that super well, bring it close, and there is absolutely no reaction whatsoever, okay. And then it says, okay, remove the nail. Okay, interaction, no. Okay, evidence that there's no change in motion, no change in anything. When you put the nail back inside, though, all right, and then bring it up, all right, you can see that there is an interaction, okay, between these two. And again, I point this way, and then I flip it around, and then the red one somewhat comes this way. All right, so it is acting like a magnet. Okay, so I put the, again, sharp nail, red is pointed towards, sorry, dull towards, this one is away. My connection might not be super strong here. Okay, so it should be acting like a magnet because it's attracting and repelling. All right, so how do you make an electromagnet stronger? I highly doubt that this one's going to pick up any paper clips whatsoever, but let's try. Alright, so I don't know. I doubt this one has the strength, given what I've seen so far, for it to pick up anything. Might help. Does this work a little bit better now? Yeah. Alright, that works a little bit better now. Come on. Alright. So, magic number picking up paper clips just with this is 0. Not very strong. Okay? I'll stop this video in class so we can brainstorm some ways to make this a stronger electromagnet. Alright? One of the ways that we can make this a stronger electromagnet is to make more coils around. So you notice how I left it pretty long. I can make both sides have more coils, and that should help. Oh, Lila's back again. Right there. Okay, so wrap this around. I don't know if this is going to be enough with this, given the battery. I think these batteries might be on their way out. Is it going to pick up? Ooh! Alright, so I was able to pick up any on this side. Oh, maybe one. Come on. some people try to cheat and pick up, you know, kind of spear it and pick it up. All right, so I was able to get 2 there by adding more coils. Okay. Another way is to add more batteries. So if I do this, all right, and I positive, again, got to make sure my positives and negatives are all lined up in the right direction. Okay. There we go. I need one more here. So if I add more cells, this should make it a little bit stronger. And it looks like it might have a little bit more. Come on, guy. Okay, I was able to get to 3 magnets now, which again, it's still pretty lame. I try to have kids troubleshoot this themselves, but you know, and I try to give them the hint of like the less resistance you have, the better the magnet will work. Okay, so how we do this? Hold on, just one sec. Sorry, we can always fast forward this, I guess. All right, so how we can do this is by reducing the resistance. So you don't need a mask in here, nobody else is in here. Okay, we can reduce the resistance of this by taking away the cell holder. Okay, that's losing electricity. The wires are losing electricity to heat. Candy back there. No, we already had enough. Next time you come in my class, I'll let you have those. Okay, on your next video that you're in here with. All right, so if I put both of these cells together, okay, and then I just attach here. Now the problem with this is that it heats up, it can heat up pretty quickly, and I mean, it's not going to burn you badly, but it does, it is enough to make you move your hands. So in this case, when I remove the resistance, I should be able to get a pretty good connection on this thing where hold on, Liz. It's still not connecting really well. Just a sec, Liz. Alright, you see how now we can get, and we've had times where it can pick up, ooh, now it's getting hot. Now it's getting hot. Okay, where it can pick up like 30 or 40 of these things pretty easily. So that one, with taking all of them away, 2, 3, 4, 5, 6, 7, 8, 9, 10, 16, 17, 18, 19, 20, 21. So 21, which again, if I had taped another one onto here and done a little bit more, I probably could have gotten up to 30, 40. Again, we've had up to 50 before pretty easily. Just reducing the resistance, making it as simple as possible. You have your cell source, you have your copper wire, and you have your magnetic material, which turns this into an electromagnet. The last part of this, as I'm breaking it down, the last part of this is a buzzer. I will say, thankfully, I'm actually glad that this isn't part of the class because it's uber annoying. Okay, but the buzzer here, okay, there's an armature inside, okay, that will vibrate, okay, against the electromagnet. So when you put this on, and I might have it backwards, but I'll find out in a sec. Yeah. No, imagine like 6 of these, and then you always have the kids in class that are going like this. Okay, the whole time. Yeah, that's how annoying it gets. So I'm not really upset that this is not part of the classroom this year. But again, this is how buzzers work: is that there's an electromagnet inside that's causing that armature to vibrate, making the buzzing noise. All right, so that's activity 5. You should be able to finish up the rest of that on your own. All right, have a good one.